This is lesson 5.3, the tangent function. So they're giving us y equals a cos theta plus d, and they're giving us the range, which is -4 to 10. So they're pretty much giving us the max and min value. So they want to find the value of the a and d value. So the a value is the amplitude, and that's always found by taking your max minus min divided by 2. So we know our max is equal to 10. Subtract our minimum, -4, and that's going to be divided by 2. So that's going to give us the answer of 7. And then our d value is the same stuff, but we're going to add between them. So max plus min now instead, divided by 2, equals 10 plus minus 4 over 2. So that'll be equal to 3. So there's our a and our d value. Our next question is asking what is the phase shift and the period for the corresponding graph. So what we need to do is always factor out the b value from this bracket. So we're going to have to go 3 factored out, which leaves us with x plus pi over 3. Close the bracket, and this is what our equation needs to be in to be able to see the phase shift and the period clearly. The period is always equal to 2 pi divided by your b value. So it's going to be 2 pi over 3. And then our phase shift is just going to be pi over 3 units. And in this case, since it's positive, it's going to be going to the left. So those are just recaps from our previous lesson. So we're looking at the tan values now. So we're looking at the tan graph. So what we need to remember is that tan is always equal to the sine theta divided by cos theta. So there are going to be asymptotes here because whenever cos theta is equal to 0, that's not going to be able to exist. So anytime that cos theta equals 0, that will be an asymptote value. So the tangent ratio is the length of the line segment tangent to the unit circle. So that's going to be point A, 1, 0 from the x-axis to the terminal arm Q. So point Q is where it ends off. And that's going to be represented by the point 1 tan theta. So that's just how it looks. And this is how it is represented on the unit circle. So for example number 1, we're going to sketch what the tan theta looks like going from -2 pi to +2 pi. So we're going to divide up our graph, and I'm going to divide them as sections of pi over 4. Okay, so this will be, the first notch will be pi over 4, then this will be pi over 2, then it will be 3 pi over 4, and the next bracket would be then pi, and then it would be 3 pi over 2, and then 2 pi. And the same thing in the negative direction. And then we want to label our y-axis. We'll go to 4, +4. Okay, so when we're looking at this, there's going to be an asymptote on cos, wherever cos is 0, and that's going to occur at every 90 degrees. So every 90 degrees, you're going to have this dotted line that the graph is going to go close to but not touch, so the vertical asymptote. Okay, so vertical asymptote there. Another one at 3 pi over 2. So it's 180 degrees from there. So I'll write it out for you guys. It's going to start at pi over 2. And then we're going to add pi which is 180 degrees, so every 180 degrees. So add pi to that, and that's going to occur. So it starts at pi over 2, and then you keep adding pi's. Okay, so our period is pi here. Okay, same thing in the negative direction. So we're going to have negative pi over 2 as an asymptote, and then pi degrees from there would be negative 3 pi over 2. And then what we're going to do is sketch a graph going through that. So it's going to go through the point 0, 0. And again, we want to be close to these asymptote values without actually touching them. So it's going to be kind of like a wave shape. It kind of looks like a cubic function if you were to draw this. So it's kind of like multiple cubic functions. And then this one's going through pi and then goes up. Same thing here. Since we want it to go up to pi, I'm going to stop it right there and then show an arrow going downwards. Goes through negative pi and then upwards. And then from upwards, it's going to go through negative 2 pi and stop there because of the domain that they're asking us to draw it over. Okay, so our period is pi. We know that the x-intercepts will occur at every pi degrees. So at pi, 2 pi, negative 2 pi. So we're going to say n pi. So every pi, n is an element of integers. The y-intercept is 0. There is no amplitude. The reason being is that the graph goes up forever, downwards and upwards, so we can't really find the amplitude. There's no max and min. The range is going to be y such that y is an element of real numbers. It goes on forever, upwards and downwards. The domain, though, we're going to have to write that x such that x cannot be all those asymptotes. So these are the asymptotes here. So we want to say that it cannot be pi over 2 plus n pi, where n is an element of integers. Okay, so all the values and everything else is allowed, so we would say xer, comma. Okay, so that's what that looks like. So it's undefined when. So remember, one thing to kind of state is it's undefined when cos theta is equal to 0. So when that happens, we have those vertical asymptotes occur. So this is our graph for our tan theta. Example number 2 is saying a small plane is flying at a constant altitude of 5,000 meters directly towards an observer. Okay, so we have an observer right here on the ground. And there's 500 meters distance, or 5,000 meters distance. Assume the ground is flat in the region close to the observer. Sketch the graph of the function that represents the relationship between the horizontal distance in meters from the observer to the plane and the angle in degrees formed by the vertical and the line of sight to the plane. So the observer seeing the plane here, and there's a horizontal distance between the plane and the actual observer. So we'll call this distance. And this is the angle that they're looking at the plane from. So in this case, when we're using our tan function, tan theta is equal to our opposite, which is our distance, over our adjacent, which is 5,000. Now we want to solve for d by moving the 5,000 to the other side. So d is equal to 5,000 tan theta. So remember that tan theta is it's going to be undefined at 90 degrees. There's no horizontal translations here, so, or sorry, there's no horizontal stretches here, so, and there's no horizontal translations either, so they're still going to be at the exact same spots that normally we would expect them at. So when we draw this, they do want us to sketch the graph that relates to this. I'll go up by 500 for the scale. And then we'll go up by 10s here. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So we're going to have this vertical asymptote right here because at 90 degrees, if this is theta, we're going to have a vertical asymptote there. And if we are in the negative direction, if we are looking and it went past us in the opposite direction, we would have also a vertical asymptote here at negative 90. So this is in degrees, and here we have the distance in meters. Okay, so we do note that the graph is still going to be at that 0, 0 origin. And so what we know is that as the plane flies towards the observer from right, the distance is actually changing. The distance is going down. So when we draw this, if you were to actually put this into your calculator, 5,000 tan theta, we're going to have a graph that looks like this. Arrows on the bottom because it keeps going in those directions, right? So sketch the graph, and we're showing the horizontal distance in meters from the observer and the angle in degrees formed by the vertical and the line of sight in the plane. Use the characteristics of tangent function to describe what happens to the graph as it flies to the right of the observer. So as the plane, so this is for B, as the plane flies towards the observer, from the right, we should see that the distance decreases. Okay, so that's all they wanted us to do for question number 2, is just sketch what this looks like and just see what we see when it comes to the graph. Okay, so it's just decreasing as it comes from the right. Okay, so that's it for lesson 5.3. Let me